Hello there. Yes, you, the one staring at this screen. Where are you right now? Are you curled up on a plush sofa in a quiet, sunlit room in London? Perhaps you're huddled over a worn wooden desk in a bustling library in Tokyo, the gentle rustle of turning pages your only companion. Or maybe, just maybe, you're stealing a few moments of quiet contemplation in a cozy cafe in the heart of Paris. The aroma of freshly baked croissants wafting through the air. Take a second, look around, see the world in its glorious, mundane, predictable motion. The steam rising from your coffee, the dust motes dancing in a sunbeam, the relentless, rhythmic tick-tock of the clock on the wall. 1 second, then the next, then the next. A steady, unyielding, universal river, wouldn't you say? It's the same for me, here, in my own little corner of existence, as it is for the astronaut currently orbiting high above us, right? Well, what if I told you that you're wrong? What if I told you that the river of time isn't so straight? What if I told you it bends, it curves, it twists and turns in the vast, silent expanse of space? What if I told you that for that astronaut you just pictured, time is actually flowing just a tiny, tiny bit slower? Intrigued? I hope so, because we're about to embark on a journey. A journey not through space, but through the very fabric of reality itself. A journey to understand one of the most mind-bending, counterintuitive, and utterly fascinating concepts in all of science. Why time bends in space, and we'll do it slowly, savoring every twist and turn of this cosmic tale. So, grab your favorite beverage, settle in, and prepare to have your perception of everything you thought you knew about time. This attic belonged to a young woman named Ilara from a very young age. Ilara had been a dreamer, her head perpetually in the clouds, blazing comets, and the silent, majestic dance of the planets. Her heroes weren't knights in shining armor, but astronomers like Galileo, Copernicus, and a certain wild-haired gentleman by the name of Albert Einstein. Her grandfather, a retired professor of physics, had nurtured this cosmic curiosity. He had been the one to gift her the magnificent brass telescope that now dominated her attic, its long barrel pointed expectantly towards a small circular window. It was through this very telescope that Ilara had spent countless nights charting the constellations, marveling at the rings of Saturn, and feeling an inexplicable pull towards the vast, silent, unknown. One crisp autumn evening, as the last rays of the setting sun painted the sky in hues of orange and purple, Ilara was meticulously cleaning the lenses of her beloved telescope. Her grandfather, a kindly man with a twinkle in his eye and a pipe perpetually clenched between his teeth, sat in a worn armchair, a thick, leather-bound book resting on his lap. "You know, my dear," he said, his voice a low, gentle rumble, "the universe is a bit like a grand, cosmic detective story, and the clues are scattered all around us, waiting for someone with a curious mind to piece them together." Ilara paused, her polishing, a thoughtful frown creasing her brow. "But Granddad," she began, her voice barely a whisper, "there's one clue that I just can't seem to wrap my head around. Time, it feels so constant, so absolute. Yet, I've been reading Mr. Einstein's work, and he talks about time as if it's something flexible. He says it can be stretched and squeezed. How can that be?" Her grandfather smiled, a slow, knowing smile that crinkled the corners of his eyes. Ah, he said, taking a long, deliberate puff from his pipe. You've stumbled upon one of the most profound and beautiful mysteries of our universe, the bending of time. He beckoned her closer. Come, sit. Let me tell you a story. A story about a mischievous little fellow named Spacetime. And so, as the stars began to pepper the darkening sky, Ilara's grandfather began to weave a tale that would forever change the way she looked at the universe. He didn't start with complex equations or dense scientific jargon. Instead, he painted a picture, an analogy that a curious mind like Ilara's could grasp. Imagine, he began, that the universe isn't an empty stage where things happen. Instead, imagine it as a giant, stretchy trampoline. This trampoline is what we call space-time. It's a four-dimensional fabric that combines the three dimensions of space, length, width, and height with the fourth dimension, time. He paused, letting the image sink in. Ilara, her eyes wide with fascination, pictured a vast, cosmic trampoline stretching out to infinity in all directions. Now, her grandfather continued, anything that has mass, from a tiny little pebble to a colossal star, creates a dip in this trampoline. The more massive the object, the deeper the dip it creates. He picked up a small, smooth stone from a nearby windowsill and placed it on the arm of his chair, a makeshift representation of the space-time fabric. The fabric of the chair sagged slightly under the stone's weight. You see, he said, pointing with the stem of his pipe, the stone is creating a little dimple. Now, imagine a much heavier object, say, a bowling ball. He gestured towards an imaginary, much heavier object. It would create a much, much deeper indentation, wouldn't it? Ilara nodded, her imagination running wild. She could almost see the cosmic trampoline, now with deep, cavernous wells created by giant stars and galaxies. Now, her grandfather said, his voice dropping to a conspiratorial whisper, here's where it gets interesting. Imagine you roll a tiny marble across this trampoline. He took a small, imaginary marble and flicked it with his finger. Yes, Ilara replied, her voice filled with anticipation. But, her grandfather continued, a triumphant gleam in his eyes, if you roll the marble near the dip created by our little stone, what do you think will happen? Ilara's eyes lit up with understanding. It would curve, she exclaimed. It would follow the curve in the fabric, precisely. Her grandfather boomed, his pipe smoke swirling around him like a miniature nebula. And that, my dear Ilara, is gravity. Objects with mass bend the fabric of space-time around them, and other objects, as they travel through space, simply follow these curves. He let that profound idea hang in the air for a moment. The only sound in the attic, the gentle ticking of the old grandfather clock in the hallway. A sound that now seemed to carry a whole new meaning. But Granddad, Ilara said, her brow furrowed. Once more in deep thought, what does this have to do with time? Her grandfather smiled his enigmatic smile once more. Ah, he said, we're getting to the very heart of the matter. You see, Ilara, time and space are not separate entities. They are inextricably linked. They are two sides of the same cosmic coin. They are space-time. He leaned forward, his voice now filled with a sense of wonder. Asterisk, to illustrate his point, he used another analogy, one that would stay with Ilara for the rest of her life. Imagine you have 2 ants, he began, crawling on our space-time trampoline. One ant is crawling on a flat part of the trampoline, far away from any massive objects. The other ant is crawling near the deep dip created by our imaginary bowling ball. He paused, making sure Ilara was following his every word. Now, he continued, if both ants crawl at the exact same speed, which one do you think will take longer to cover the same distance? Ilara thought for a moment, her mind's eye picturing the two tiny creatures on their cosmic journey. The one near the bowling ball, she said, a wave of realization washing over her, because it has to travel down into the dip and then back out again. It has a longer path to cover. Exactly, her grandfather exclaimed, his face beaming with pride. And that, my dear Ilara, is the essence of time dilation. For the ant near the massive object, its journey is longer. And since time is part of this fabric, time itself for that ant flows more slowly compared to the ant on the flat part of the trampoline. A profound silence descended upon the attic, broken only by the distant hoot of an owl. Ilara sat there, her mind reeling, trying to process the sheer magnitude of what her grandfather had just explained. Time, the one constant in her life, the unwavering rhythm of her existence, was not constant at all. It was a flexible, malleable entity, intertwined with the very fabric of the cosmos, and its pace was dictated by the silent, and yet, in the elegant simplicity of her grandfather's analogies, it made perfect, beautiful sense. She looked at her grandfather, his face illuminated by the soft glow of the single bare bulb hanging from the attic's rafters, and saw not just her loving guardian, but a storyteller, a weaver of cosmic tales, who had just gifted her a key to unlock one of the universe's most profound secrets. That night, as Ilara lay in her bed, the stars outside her window seemed to twinkle with a newfound meaning. They were no longer just distant points of light. They were massive cosmic clocks, each ticking at its own unique pace, their rhythm dictated by the invisible curvature of spacetime they created. And as she drifted off to sleep, her dreams were not of fantastical beasts or faraway kingdoms, but of a vast, cosmic trampoline, and of two tiny ants on a journey through the warped and wonderful landscape of a universe where time itself could bend. The seeds of curiosity, planted by her grandfather that evening in the attic, blossomed within Ilara, fueling an insatiable thirst for knowledge. She devoured every book on cosmology and astrophysics she could get her hands on. Once just fascinating stories were now the central focus of her intellectual pursuit. Her grandfather, ever the nurturing guide, watched her passion grow with a quiet, knowing pride. He would often find her in the early hours of the morning, hunched over complex equations, her face illuminated by the glow of her desk lamp, a look of intense concentration on her face. He knew that the simple analogies he had shared with her were just the beginning of her journey. The time had come to introduce her to the more intricate, more mathematical, and even more mind-bending aspects of Einstein's revolutionary ideas. One rainy afternoon, as the pitter-patter of raindrops against the window pane provided a soothing soundtrack, Ilara's grandfather brought out a large, worn chalkboard, a relic from his teaching days. He set it up in the middle of the living room, a mischievous twinkle in his eyes. "All right, my budding cosmologist," he said, a piece of chalk in his hand. "Are you ready to take a peek behind the curtain, to see the machinery that makes the universe tick?" Ilara, her eyes gleaming with anticipation, nodded eagerly. She knew this was the next step, the bridge between the conceptual understanding she had gained and the rigorous scientific framework that underpinned it. Her grandfather began not with equations, but with a story about a man who dared to question the very foundations of physics. Early years, his rebellious spirit, his insatiable curiosity, and his unwavering belief in the power of imagination. He described how Einstein, as a young man, had pondered a simple yet profound question. What would it be like to ride on a beam of light? Imagine, Ilara, her grandfather said, his voice filled with a sense of awe, to travel at the speed of light, the ultimate speed limit of the universe. What would you see? Would you see a stationary, frozen wave of light? The laws of physics, as they were known at the time, seemed to suggest so. But Einstein, with his incredible intuition, knew that this couldn't be right. It violated one of the fundamental principles of physics, the principle of relativity, first formulated by Galileo. He then proceeded to explain the principle of relativity in simple, accessible terms. No matter how they are moving, as long as they are not accelerating. If you are on a smoothly moving train, for example, and you throw a ball up in the air, you wouldn't be able to tell you were moving without looking out the window. But, he continued, if you were to ride on a beam of light, and you saw a stationary wave of light, that would mean that the laws of electromagnetism, which describe the behavior of light, would be different for you than for someone standing on the ground. And that, for Einstein, was a major problem. It was a contradiction that he was determined to resolve. It's the same for all observers, regardless of their own motion. Ilara's brow furrowed. But Granddad, she interjected, how can that be? If I'm on a train moving towards a light source, shouldn't I measure the speed of light to be faster than someone who is standing still? Her grandfather smiled, a knowing, patient smile. That's what our everyday intuition tells us, my dear. Of light to be constant for everyone, something else had to give. And that something was our long-held, cherished notion of absolute space and absolute time. He then drew two diagrams on the chalkboard. One depicted a stationary observer, and the other an observer on a moving train. He showed how, for the speed of light to remain the same for both observers, their measurements of distance and time would have to be different. This is the essence of special relativity, he explained, his voice filled with a reverence for the beauty of the theory. Time and space are not absolute. They are relative. They are interwoven into a single entity, spacetime, and they can be stretched and squeezed depending on your motion. He went on to explain the famous twin paradox, a thought experiment that perfectly illustrates the consequences of time dilation due to velocity. He described two twins, one who stays on Earth and the other who embarks on a journey to a distant star at near light speed. When the traveling twin returns, he finds that he has aged less than his styatome sibling. Time for the traveling twin has literally flowed more slowly. Ilara listened. The idea that two people could experience the flow of time differently was both bewildering and exhilarating. It was as if she was being given a glimpse into a hidden layer of reality. A reality where the familiar, steady rhythm of time was just an illusion. But her grandfather wasn't finished yet. He then moved on to the next chapter of Einstein's cosmic saga, the general theory of relativity. Special relativity, he explained, deals with constant velocity. But what about acceleration? What about gravity? Einstein knew that his theory was incomplete. He spent the next 10 years grappling with this problem, and the solution he came up with was even more revolutionary, even more mind-bending than special relativity. He then returned to his analogy of the spacetime trampoline. Einstein's great insight, he said, was that gravity is not a force. It is a manifestation of the curvature of spacetime, and this curvature is caused by mass and energy. He wrote down the famous Einstein field equations on the chalkboard, a set of 10 complex, beautiful equations that describe the fundamental interaction of gravitation as a result of spacetime being curved by matter and energy. Ilara, though, she couldn't fully grasp the mathematical intricacies of the equations, could appreciate their elegance and power. They were like a cosmic recipe, tells matter how to move. And it is this curvature of spacetime, her grandfather concluded, his voice filled with a sense of triumph, that causes time to bend. Just like the ant on the trampoline, a clock in a stronger gravitational field will tick more slowly than a clock in a weaker gravitational field. Time itself is a victim of gravity's gentle, relentless pull. Of astronomers, led by Sir Arthur Eddington, had traveled to the island of Principe off the coast of Africa to observe the eclipse. They had measured the positions of stars near the sun and found that their light was indeed bent by the sun's gravity, just as Einstein's theory had predicted. The story of Eddington's expedition, of the scientific community's initial skepticism, and of the eventual triumph of Einstein's theory, filled Ilara with a sense of inspiration. It was a testament to the power of human curiosity, to our relentless pursuit of knowledge, and to our ability to unravel the deepest secrets of the cosmos. As the rain outside began to subside, and a sliver of sunlight broke through the clouds, casting a rainbow across the sky, Ilara looked at the chalkboard, at the equations and diagrams that now seemed to hold the secrets of the universe. She looked at her grandfather, his face filled with a quiet satisfaction, and felt a surge of gratitude. He had not just taught her about science. He had ignited a fire within her, a passion for understanding the universe in all its strange and wonderful glory. The conversation that rainy afternoon marked a turning point in Ilara's journey. The world of theoretical physics, once an intimidating landscape of complex mathematics, now felt like an inviting, explorable terrain. With her grandfather's guidance, she began to delve deeper into the intricacies of general relativity, her initial fascination transforming into a profound and abiding passion. She spent her days poring over textbooks, her nights filled with dreams of warped space-time and ticking clocks in different gravitational fields. The abstract concepts began to take on a tangible quality in her mind. She could almost feel the fabric of space-time, could almost hear the subtle variations in the rhythm of time as she imagined herself journeying through the cosmos. One evening, as they sat by the fireplace, the crackling flames casting dancing shadows on the walls, Ilara posed a question that had been brewing in her mind for some time. "Granddad," she began, her voice filled with a mixture of curiosity and trepidation, "if time really does slow down in strong gravitational fields, does that mean that time on the surface of the Earth is slower than time in space?" Her grandfather, who had been dozing off in his armchair, opened one eye and smiled. "A very astute question, my dear," he said, his voice a low, gentle rumble. "And the answer is yes. Time on Earth does indeed run slightly slower than it does for, say, a satellite orbiting high above us. He then proceeded to explain the practical, real-world implications of this phenomenon. He told her about the Global Positioning System, or GPS, the network of satellites that allows us to pinpoint our location on Earth with incredible accuracy. You see, Elara, he explained, the clocks on those GPS satellites are in a weaker gravitational field than we are on the surface of the Earth. According to general relativity, their clocks should tick slightly faster than our clocks here on the ground. At the same time, the satellites are moving at very high speeds, and according to special relativity, their clocks should tick slightly slower. So, which effect wins? Elara asked, her interest piqued. Well, her grandfather replied, it turns out that the effect of general relativity is stronger. The clocks on the GPS satellites gain about 45 microseconds every day compared to clocks on Earth. And if we didn't account for this tiny, almost imperceptible difference, the entire GPS system would be utterly useless. Within a matter of minutes, the errors in its positioning would accumulate to the point where it would be telling you that you're in the middle of the ocean when you're actually standing in your own living room. The idea that the abstract, esoteric theories of a wild-haired physicist from the early 20th century were now an indispensable part of our everyday technology filled Elara with a sense of wonder. It was a powerful reminder that even the most arcane and seemingly impractical scientific discoveries can have a profound and lasting impact on our lives. But her grandfather wasn't finished yet. He then took her on a journey to the most extreme, most mind-bending environments in the universe. Places where the curvature of spacetime is so intense that our everyday intuition completely breaks down. He spoke of neutron stars, the incredibly dense remnants of massive stars, where a single teaspoon of matter would weigh billions of tons. On the surface of a neutron star, he said, his voice filled with a sense of awe, the gravitational pull is so immense that time would be slowed down by as much as 30%. If you were to spend a year on the surface of a neutron star and then return to Earth, you would find that more than a year and a half had passed for your friends and family. And then he took her to the ultimate cosmic abyss, the place where the laws of physics as we know them cease to exist, the point of infinite density and infinite gravity, a black hole. A black hole, he explained, his voice dropping to a whisper, is a region of space-time where gravity is so strong that nothing, not even light, can escape. It is a cosmic prison from which there is no return. He described the event horizon, the point of no return, the boundary beyond which the escape velocity exceeds the speed of light. He painted a vivid picture of what it would be like to fall into a black hole, a journey that would be both terrifying and strangely beautiful. As you approach the event horizon, he said, you would see the universe outside speeding up. You would see stars being born and dying in the blink of an eye. You would see the entire future of the universe unfold before you in a brilliant, fleeting spectacle. And what would happen to time for me? Elara asked, her voice barely a whisper. For you, her grandfather replied, his voice filled with a somber reverence, time would slow down to a standstill. As you cross the event horizon, time, as you know it, would cease to exist. You would be frozen in time, forever trapped at the edge of eternity. The image of a black hole, a place where time itself comes to an end, sent a shiver down Ilara's spine. It was a concept so profound, so terrifying, and yet so utterly captivating. It was the ultimate manifestation of the bending of time, the final dramatic act in the cosmic play of gravity and spacetime. The conversations with her grandfather, the journey from the gentle slopes of spacetime to the terrifying precipice of a black hole had a profound and lasting impact on Ilara. They had not just answered her questions. They had opened up a whole new universe of questions, a whole new realm of cosmic mysteries to explore. She knew that her journey of understanding was far from over. In fact, it had just begun. The attic, the telescope, the chalkboard, and the stories of her grandfather had been her spaceship, her vessel for exploring the cosmos from the safety and comfort of her own home. But now she felt a yearning for something more, a yearning to be closer to the stars, to be a part of the grand cosmic detective story that her grandfather had so beautifully described. And so, with a heart full of dreams and a mind full of questions, Ilara made a decision. She would dedicate her life to unraveling the mysteries of the universe. She would become an astronomer, a cosmologist, a seeker of cosmic truths. Her grandfather, when she told him of her decision, simply smiled, a quiet, knowing smile. He knew that the little girl with her head in the clouds had finally found her true calling. She was no longer just a dreamer. She was a traveler, an explorer, a voyager on the endless ocean of cosmic knowledge. And as she set out on her new journey, the words of her grandfather echoed in her mind, a constant reminder of the profound and beautiful truth that had set her on this path, that in the vast, silent expanse of space, in the grand, cosmic dance of matter and energy, time itself is not a straight, unyielding river, but a winding, bending, beautiful stream, its course forever shaped by the gentle, relentless pull of gravity. The story of why time bends in space was not just a scientific concept for Ilara anymore. It was her story. It was the story of her life. Years passed. The little girl from the attic in the English countryside was now a woman, a respected astrophysicist at a prestigious observatory nestled high in the Chilean Andes. The dusty attic had been replaced by a state-of-the-art control room, the brass telescope by a colossal instrument capable of peering into the deepest, darkest corners of the cosmos. Ilara had dedicated her life to the study of black holes, those enigmatic cosmic behemoths that represented the ultimate test of Einstein's theories. She spent her nights bathed in the soft, ethereal glow of computer screens, analyzing data from distant galaxies, searching for the telltale signs of these invisible giants. Her grandfather, though he was no longer with her, remained her constant source of inspiration. His voice, his wisdom, his passion for the universe were etched into the very fabric of her being. She often found herself staring up at the star-studded sky, the same sky she had marveled at as a child, and feeling a profound sense of connection to him, to the universe, and to the endless, beautiful mystery of time. One fateful night, as Ella and her team were observing a distant quasar, they noticed something strange, a subtle, periodic dimming in the quasar's light. It was a tiny, almost imperceptible fluctuation, but it was enough to send a jolt of excitement through the control room. After weeks of painstaking analysis, they confirmed their suspicions. They had stumbled upon a binary system, a pair of black holes locked in a cosmic dance of death, spiraling ever closer to each other. The discovery was monumental. It was the first time that such a system had been observed, and it provided an unprecedented opportunity to study the effects of extreme gravity on spacetime. It was a chance to witness, firsthand, the bending of time in its most dramatic form. The world's scientific community was abuzz with the news. Telescopes from all over the globe were pointed towards the distant quasar, all eager to catch a glimpse of this cosmic spectacle. But Alara knew that the most profound insights would not come from observing the black holes themselves, but from listening to them. She knew that, as the two black holes spiraled towards each other, they would be sending out ripples in the fabric of spacetime, ripples known as gravitational waves. And these waves, if they could be detected, would carry with them the story of the black hole's final, violent embrace. They would be a symphony of spacetime, a cosmic song that would tell of the bending of time, the warping of space, and the ultimate triumph of gravity. The race was on. A global network of gravitational wave detectors, massive L-shaped instruments buried deep underground, was on high alert, waiting for the telltale chirp that would signal the arrival of the waves. For months, Alara and her team waited there, anticipation growing with each passing day. And then, one cold, clear night, it happened. A faint, almost imperceptible signal, a tiny tremor in the fabric of spacetime, was detected by the detectors. The signal was faint, but it was unmistakable. It was the sound of two black holes, millions of light years away, merging into one. It was the sound of spacetime itself ringing like a bell. The analysis of the signal confirmed everything that Einstein's theory had predicted. It showed the two black holes circling each other, their orbits decaying as they radiated away energy in the form of gravitational waves. It showed the moment of their merger, a cataclysmic event that released more energy in a fraction of a second than all the stars in the observable universe combined. And it showed the final ringing down of the newly formed black hole as it settled into its new, stable state. But for Alara, the most profound revelation came from the subtle details of the signal, the tiny variations in its frequency and amplitude. These variations were the signature of the bending of time, the slowing down of time in the intense gravitational field of the merging black holes. She could almost see it. The two cosmic behemoths, their event horizons merging, their singularities combining, and in that final, fleeting moment, time itself coming to a standstill. The discovery was a triumph, a testament to the power of human ingenuity and our relentless pursuit of knowledge. It was a confirmation of a century-old theory, a theory that had been born in the mind of a single man, and that had now been proven by the collective efforts of thousands of scientists from all over the world. For Alara, it was more than just a scientific breakthrough. It was a personal journey that had come full circle. The little girl who had once gazed at the stars with a sense of wonder, who had listened with rapt attention to her grandfather's stories of a bending, twisting river of time, had now, in a way, touched that river. She had listened to its song, she had felt its ripples, and she had come to understand, in a way that she never thought possible, the profound and beautiful truth that lay at the heart of her lifelong passion. As she stood on the balcony of the observatory, the cool mountain air on her face, the star-studded sky stretching out before her like a vast cosmic tapestry, she thought of her grandfather, She thought of his stories, his wisdom, his unwavering belief in the power of curiosity. And she knew that he would be proud. The story of why time bends in space was no longer just a story for her. It was a part of her, a part of her own personal history, a part of the grand cosmic detective story that she had dedicated her life to unraveling. And as she looked up at the silent, majestic dance of the cosmos, she knew that there were still so many more clues to be found, so many more mysteries to be solved, so many more chapters to be written in the endless, beautiful story of the universe. And she was ready, ready to continue her journey, to follow the winding, bending river of time, wherever it may lead. The adventure, she knew, had only just begun.